Okay, it's time for 5.2 review. And we're going to start by solving this system by elimination. That means add the equations or multiples of the equations together to eliminate a variable. Well, in this case, we can just add these two equations together. Left side added to the right side, or left side added to left side, right side added to right side, and the y's disappear. So we add the 2x plus 4x is 6x, y plus negative y is 0y, 4 plus 20 is 24. So now we can solve this single equation with only one variable for that variable. 6 times 4 is 24. So x is 4. We can plug that answer into either of these equations to solve for y. So why don't you do that? Now, there's usually an easier and harder way of doing this. I'm going to plug the 4 into the top equation because we have plus y rather than minus y. So 2 times 4 plus y equals 4. 8 plus y equals 4. Y is 4 minus 8, or negative 4. And we can check that by plugging into both equations. 4 times 4 minus a negative 4 does equal 20. So our answer here is x equals 4, y equals negative 4. Okay, for the next example, we're going to solve by elimination. But here we see if we add the equations as they are, we get 6x minus 2y equals 22. Well, that has both x and y in it. That doesn't do us any good. So we have to multiply or add multiples of equations to eliminate a variable. Now you really have two choices here. You could multiply the top equation by negative 2 to make this negative 4x added to the 4x, or we could multiply the bottom equation by positive 3 so that when we add the negative 3y to the positive 3y, we end up getting rid of a variable. You can do it either way, and I would probably suggest doing the positive 3 here. So multiply both sides of this equation by positive 3, then add equations. So do that multiplication, add the equations, eliminate the y variable, and solve for x. So when we do that multiplication and then add our equations, the 2x and 12x add up to 14x. The negative 3y plus positive 3y makes 0y. Negative 2 added to 72 is 70. So now we have one equation, one unknown. We can solve it. 14x equals 70. Divide both sides by 14. And 70 divided by 14 is an even 5. Because 5 times 14 is 50 plus 20, or 70. So we got one answer, x equals 5. And now we can plug that in to find the y value. So why don't you do that? Pause the video and find the y value. And you can plug that 5 value for x into either equation. I'm going to pick the second equation just because it's positive 3y rather than negative 3y. But the first one would also work just fine. Plugging 5 in, we get 60 plus 3y equals 72. Subtract 60 from both sides. 3y equals 12. And then divide both sides by 3. Y equals 4. So our answer here is x equals 5, y equals 4. Okay, the next system we're going to solve by elimination. 3x plus 2y equals 7, and 2x minus 3y equals 1. Now, here we can't just multiply one of these equations by one positive or negative number and then get rid of a variable, because it just doesn't quite work. I guess we could multiply the bottom equation by 3/2 and work with fractions. And that does work. Or multiply the top equation by 2/3 on both sides. But that's a little bit tricky. The way that most people would like to do this is multiply one equation by one number and the other equation by another number to cancel out a variable. We can get rid of the x's if we multiply the top equation by 2, making it 6x, and then the bottom equation by -3 on both sides to make it -6x, and then when we add equations, the x's will disappear. Now there's other options too. We could have multiplied the top equation by 3 to make it 6y, and the bottom equation by +2 to make it -6y. That would have worked just as well. There's lots of different options on these. But why don't you multiply through on both sides to start here so that we get the same equations to work with. So we multiply the top equation by 2. We get 6x plus 4y equals 14. The bottom equation by -3, -6x plus 9y. A negative times a negative makes the positive 9y equals -3. Now we add these two together, big plus sign. The 6x and -6x makes 0 x's, 4y and 9y makes 13y. 14 minus 3 is 11. Okay, so now we just divide both sides by 13, and we get y equal 11/13. I guess that's unfortunate, it's a fraction, but we have to deal with fractions. So now what you need to do is plug the 11/13 into either equation and solve for x. Now I'm going to use the second equation. Either equation will work, but I'm going to pick the second equation, plugging in y equal 11/13 for this y value. So you get 2x minus 3/1 times 11/13. We have to write 3 as 3/1 to multiply the fractions. And now we just do the fractions, add that fraction to both sides, and solve for x. So see if you can't solve this for x. Some fraction review here, which is always good. So we plug in 11/13 and multiply 2x minus 33/13 equals 1. Add 33/13 to both sides, so 2x equals 1 plus 33/13. We have to write 1 as 13/13 in order to add it to the 33/13. So 2x equals 46/13, but now we need x. So to get x, we need to multiply both sides of this equation by 1/2. So when we multiply both sides of the equation by 1/2, 1/2 times 2x, we get x equals 46/26, which reduces to 23/13. So that's our x, 23/13. Our y is 11/13. Now you might be shaking your head, oh, this is awful. This is awful, all these fractions. Isn't there a better way? Well, we could have found x by doing elimination of the y variable. So you can eliminate the x variable to get y to the 11/13. Then we go back to our original system. To get rid of the y variable, multiply the top equation by 3, the bottom equation by 2. And the new system you get is 9x plus 6y equals 21. 4x minus 6y equals 2. And now we add those two together and look what we get. 13x equals 23. Aha! X is 23 thirteenths. So we got that answer without doing the fractions. So it's okay. You can do elimination on two different variables, you know, in the same problem and save yourself some work with the fractions. Okay, that's it for 5.2 review. If you have more questions, post them on discussions.